Here is a video for grade 10 equations. So I've broken it down into the 6 types of equations that you can get. So the first type, linear, then quadratic equations with fractions, literal equations, simultaneous equations, and exponential equations. And I'll go through each one separately. Before we start, the general steps to solving equations. So you first want to get rid of any brackets by distributive law, which is when you rainbow into a bracket. For fractions, you also want to get rid of fractions. So you do this by multiplying each term by all the denominators. And you also then want to get all the variables to one side and all the numbers to the other side. Preferably you want to get variables to the left and numbers to the right, but you can do it in reverse as well. Remember, when something moves across the equal sign, it changes its sign. So if it's positive, it will change to a negative if you've moved it across. Then you need to simplify both sides as far as possible, and then finally get the variable by itself. So if it has a coefficient, you need to divide every term by that coefficient on both sides if needed in order to get the variable by itself. If the variable is negative, so negative x, for example, you want to solve it so that it's negative. You divide each term by negative, so you get just an x. Okay, so then let's jump into the question. So linear equations. So these are the most simplest types. So if there are brackets, you need to multiply into the brackets to remove the bracket. Then all variables to the left, all numbers to the right, and then get the variable by itself, divide by the coefficient. Okay, so let's start this example. Solve for x in each of the following equations. 13 minus 2x equals 9x minus 9. So variables all to the left. So the 9x becomes minus 9x. And then on the right-hand side becomes minus 9 minus 13. And now we just need to solve. So group-like terms, so minus 11x equals minus 9 minus 13 is minus 22. And then we're dividing by minus 11 on both sides. So x is equal to 2. Okay, so that should make sense. A trick or a tip that you can use is that you can use your calculator to check your answer. So what you would do there is you substitute x is minus 2 into the left and see what you get, and do the same thing for the right. So if I had to do that quickly, it's 13 minus 4, because minus 2 times 2 is minus 4, and that gives us 9. Let's do it on the right hand side. 9 times 2 is 18. Minus 9 is 9. So we have 9 equals 9. So that's how you know that you've done it correctly. So that's a check for you to do. You don't have to write that down in a test, but you can do it on your calculator to check yourself. That's the nice thing about this section, is you can, for the most part, check yourself. Next one. So in this example, we need to get rid of the brackets first. So we'll times in distribute the 3, distribute the 4. 3x minus 9 plus 4x minus 4 equals 1. We'll keep the x's on this side, take everything else over. So 1 plus 9 plus 4. We're changing the signs when we're crossing the equal sign. 7x equals 14. Divide both sides by 7. So that's showing you where you're dividing by the coefficient of the x, the variable. 7 goes into 14 twice. Therefore, x is equal to 2. Okay. Next one. Again, multiply into the bracket. 6x plus 2 equals 7 minus 4x. Numbers to the one side, variables to the other. So 6x plus 4x, because we've crossed the equal sign, it changes to a positive 4x. Likewise, 7 minus 2. 10x equals 5. Divide both sides by 10. X is equal to, you could do this fraction on your calculator. X is equal to a half. Okay. Next is quadratic equations. So these are important because they relate to trinomials and they relate to your parabola functions. And you would have to work with these to a certain degree in your function section when you're working out the x-intercepts of your parabolas. So when we set a quadratic equation to 0 and we solve for x, that's where we're finding the x-intercepts. In other words, your x-cuts of your parabola. That's what these quadratics do. So quadratic equations have a squared value, which means you usually have two answers. Not always, but most of the time. So if you see a trinomial or a quadratic, you bring everything to the left and equal it to 0. And then you factorize the trinomial. You could bring everything to the right as well. It's best to take it to whichever side will have the x squared value as positive. And then each trinomial bracket needs to be equal to 0. And then we solve for each. That's where you get your two answers. So for example, solve for x in the following equation. I know that it's quadratic because of the square. And then I just have a variable x and then just a constant value of 2. So it descends power of x. So it goes x squared, x, no x. So that's how I know it's a quadratic. So first thing would be to, because everything's brought over to the same side, that's good. Then I just need to factorize. So as a trinomial, this will factorize out to x plus 2, x plus 1 equals 0. Then each of these are factors. Okay, so then we make each of the factors equal to 0. So x plus 2 equals 0, or x plus 1 equals 0. We have to put both. And then we just solve each of these small linear equations. So x is equal to minus 2, x is equal to minus 1. What you can see here happening is the sign just changes from the bracket to get to your solution when the coefficient of x is just 1, as in this example. Okay, so if you had to then check yourself, let's do a check for the x equals minus 2. So I'm going to then, in my original question, minus 2 squared plus 3 times minus 2 plus 2. And we're expecting the answer to be equal to 0 in order for it to work. So that is 4 minus 6 plus 2. 4 minus 6 is minus 2 plus 2 is 0. So therefore we know that we've done the correct thing. Another one. So this one, question B, has already been factorized for you. X minus 3, x minus 7. So all you have to do here is make each factor bracket equal to 0. So x minus 3 equals 0, or x minus 7 equals 0. Therefore, x is equal to 3, or x is equal to 7. So that's the simplest type of question you can get for quadratics, when they give you the two brackets and you just have to make them equal to 0. The next one, this one doesn't have a constant value. So usually you used to 3x squared minus 5x minus 2, for example. You usually used to seeing the 3 different values. We treat it similarly, but we can do common factor here. So the common factor is x. So then in our bracket, we're left with 3x minus 5 equals 0. We treat it the same now. This is a factor on the outside of the bracket, and the bracket is a factor. So we still make each factor equal to 0. So x equals 0, or 3x minus 5 equals 0. Obviously, the x equals 0 is already solved, so that's the one solution. The other solution would be 3x equals 5. The 5 taken over, so it becomes positive. And we divide both sides by 3. So x is equal to 5 over 3. And there's your two solutions, 0 and 5 over 3. The same thing happens with question D, except they've already taken out that common factor. The original one would have been 5x squared plus 2x, and they've just taken out the common factor. So all we have to do is make each of the factors equal to 0. Divide both sides by 5. X is equal to minus 2 over 5, or x is equal to 0. The next one. There's two ways to go about this one when you have an x squared and then just a number value. You can either take over the 25 to the other side, or you can do a dots. I'm going to do a dots method, or actually I'll show you both. So x minus 5, x plus 5, difference of two squares, dots. And we make each factor bracket equal to 0. X minus 5 equals 0, or x plus 5 equals 0. And solve each of those. So x is equal to 5, or x is equal to minus 5. The other method would be if we took over the 25, the minus 25 to the other side, so it becomes 25, and then we square root both sides. But what happens when you square root is you have to plus minus, because the original number could have been positive or negative, because a positive times a positive gives us a positive, and a negative times a negative gives us a positive. So we're not sure what if it was originally a negative or a positive, so we have to put both. So then your solution here is x is equal to plus or minus 5, and written out it's x equals 5 or x equals minus 5. So you can see we got to the same place with these two different methods. And you can choose to do either method. I think because we're used to all the factorizing, it's probably easier to remember to do the difference of two squares. But if you perhaps forgot that in a test situation, you can still do this other method as well. Question F. So I can see again that this is a trinomial or a quadratic because of the square, then just an x, and then just a number. So your step is to bring everything to the same side. So 2x squared minus 7x plus 3 equals to 0. And now this is a trinomial, so let's factorize it. Doing this method. So 2x and x, the two factors of 2x squared, and 3 and 1. 2 times 3 is 6x. X times 1 is x. How do we get to negative 7? We have to have a negative x and a negative 6x. Then swing those signs over, and there are your two factor brackets. 2x minus 1 and x minus 3 equals to 0. And now we make each of these factor brackets equal to 0, and we solve. So x is equal to, I'm just going to jump steps here, x is equal to a half. We first bring the 1 over, divide by 2, and x is equal to 3. And those are your two solutions. Okay. Then equations with fractions. So these are a bit more tricky, and you need to concentrate a bit for these. So the goal is to get rid of the fractions. In order to do these, we then multiply each term by the LCD of all the fractions. So we first need to figure out what's our LCD. If there are variables in the denominator, we need to state the restriction that makes the denominator equal to 0. So for example, if I have 4 over x, what makes this undefined is 4 over 0, if x is 0. Because if you put 4 over 0 in your calculator, it's going to give you an error message, because you can never have a 0 at the bottom of a fraction. So for these questions, if there's a variable in that denominator, in any of the denominators, we need to give the restriction as well. If you don't do this in a test, you might lose 1 mark per question. So it's always best to do this. So for example, in question 1, what would this restriction be of this question? So we take whatever the denominator is and we equal it to 0. So x minus 4 equals to 0, and it cannot equal 0. So that's why we put a line through the equal sign, which means not equals to. And then we solve it. So x is not equals to 4. So we treat it like an equation, except it's a not equals sign. So if we get an x value of 4, this equation would not work because it would make this denominator equal to 0. If we had to substitute in 4 there, 4 minus 4 is 0. Let's do the next one, question 2. So we take the denominator with a variable, x plus 1 cannot equal to 0, and then solve it. So x cannot equal to minus 1. For this next one, there's multiple ones. There's 1, 2, and 3. We have to do them all separately. So x plus 6 cannot equal to 0, so x cannot equal to minus 6. So that's the first fraction. That second one, x, just by itself, x cannot equal to 0. Then the last one, 2 minus x cannot equal to 0. Minus x cannot equal to minus 2. Divide both sides by minus 1. So x cannot equal to 2. Okay, so we always need to state these restrictions or else you will lose marks. You will lose only 1 mark per question, but that 1 mark could be a difference between a symbol in your final mark. Okay, then let's see how we do these. Solve for x in each of the following equations. So you want to get rid of the fractions. So what we have to do here is multiply by the LCD. Each term by the LCD. The LCD would be 5 and x minus 4. Basically, it's the two denominators multiplied together. This will happen most of the time because you want something, a value that both of these original denominators can divide perfectly into. Then what we do is we multiply each term by that value. So multiply 5 x minus 4, and the same for the other term, times 5 x minus 4. What happens then is the 5 cancels with the 5, because the 5, this multiplication that we've added in blue, sits at the top of the fraction, so we can cross cancel. And the x minus 4 cancels with the x minus 4. Then we have to multiply what's remaining over. So we have that blue x minus 4, and then the x minus 4 from the actual fraction, equals to the other side, which is 5 times 5. So we have 25, and then we can do the FOIL, x squared minus 4x minus 4x plus 16. Now we can see what's happening here is that we're getting to a trinomial because I can see the squared, I can see x values, and I can see constant values, just numbers. So let's do this. X squared minus 8x, and then I'm going to bring the 25 over. 16 minus 25, which is minus 9, equals 0. Now we have to do the trinomial on this. So x squared minus 9 on the other side, minus 8x. The factors of x are x and x. For 9, I can see that we need to get to an 8. So if I use the factors of 3 and 3, there's no way to get to 8 from 3 and 3. So it would have to be 9 and 1. So it's just 1x there and 9x there. It would have to be a minus 9 plus 1 will get us to minus 8. Swing over those signs. And there are our two factors. And then we have to say x equals 9 or x equals minus 1. But then remember, you need to state your restrictions. So your restriction is this denominator equal to 0, not equal to 0. I'll do this in pink. x minus 4 is not equal to 0, so x is not equal to 4. Always then check your solution against your restriction. If we had to get a solution of x equals 4, then we would have to cancel that solution out because of the restriction. Okay, next one. So our LCD here would be 2 times x plus 1, and that's what we multiply each term by, times 2x plus 1 times 2x plus 1. Then do the cross cancelling. 2 cancels with 2, x plus 1 cancels with x plus 1. Then we're left with 3x multiplied by x plus 1 equals 2 times 5x minus 1. Then multiply out these brackets. So 3x squared plus 3x equals 10x minus 2. Again, I can see it's a trinomial because there's a squared, there's x's, and there's a constant. So we bring everything over to the left. 3x squared. 3x minus 10x would be minus 7x plus 2 equals to 0. Let's do the factors. 3x squared plus 2 on the other side, the middle term, minus 7x. The factors of 3x squared are 3x and x. And then 2 and 1. The 2 would have to go there, the 1 would have to go at the top, because I know I'm getting to a 7, so 2 times 3 is 6x, x times 1 is x. And they would both have to be a minus, and then swing it over. So your factors, 3x minus 1 and x minus 2 is equal to 0. Therefore, 3x is equal to 1. So x is equal to a third. That's your one solution. Your other solution, x minus 2 equals 0. X is equal to 2. Okay. Our restrictions for this question. X plus 1 not equal to 0. So x not equal to minus 1. Minus 1 doesn't appear as any of the solutions, so that's good. Both of our solutions are valid. Then let's move on to a trickier one, because now there's lots of different denominators. So the LCD would be the multiplication of all of them together. So x times x minus 2 times x plus 6. Always good to use brackets. So now we have to multiply each term by that whole LCD, every single term. So this can get a bit messy. And this term on the left as well. Okay, then we're going to cancel out. So this x plus 6 cancels with x plus 6. X cancels with x. X minus 2 cancels with x minus 2. Now we're going to be left with some stuff. We're left with, in that first fraction, we're left with a 3 times x. So that's the 3 from the fraction and then the x from the outside of the LCD, as well as x minus 2, plus 4, and that 4 is left with those two brackets, x minus 2x plus 6, equals to the 5 is left with the x as well as x plus 6. And now we just multiply these out. 3x squared minus 6x plus 4, and then a square bracket to do these two FOIL brackets, x squared plus 6x minus 2x minus 12 equals 5x squared plus 30x. Okay, let's simplify. 3x squared minus 6x. We can multiply this 4 in now. Plus 4x squared. I know that these two terms in the brackets, 6 minus 2 comes to 4x. So 4 times 4 is plus 16x. And then times 4 and minus 12. So that is 48. Minus 48. Yeah. Equals 5x squared plus 30x. Again, I can see this is a trinomial, unless all the terms cancel out. But 3x squared plus 4x squared minus 5x squared from the other side, minus 6x plus 16x minus 30x from the other side, minus 48 equals 0. Let's neaten that up. 3 plus 4 minus 5 is 2x squared. Minus 6 plus 16 is minus 30 as well, is minus 20x. Minus 48 equals 0. This is now one of those trinomials where the coefficient of x squared can be taken out as a common factor. And what I'm going to do here is I'm going to divide each term by 2, which is a perfectly acceptable thing to do. So we're left with x squared minus 10x. 48 divided by 2 is 24 equals 0. And this is now a trinomial. X squared minus 24. That should be a minus 10x. So x and x. How do I get to 10? What factors of 24 can get me to 10? Well, 4 and 6. So 6x and 4x, and they both have to be minus. So x minus 4, x minus 6 equals 0. So x is equal to 4, x is equal to 6. I've just skipped a step there. Okay. Then question D. I'm just going to erase some of this. Okay. Actually, I'm going to leave that in. I will start here. So for this question, the LCD is now going to be, we need an x. And then in terms of the numbers, we need the lowest common multiple of 6, 2, and 3, which would be 12. So that's what we multiply each term by, times 12x. The 1 also needs to be timesed. Okay, then x's cancel, 6 goes into 12 twice. The x's cancel, 2 goes into 12 6 times. The 1 is over a 1, so 1 goes into 12x times, so we leave it. The x cancels with the x, 3 goes into 12 4 times. That's a bit messy, but you should be left with then 2 times 5 minus 6. I'm just double checking that. Yes, minus 6, because there's a 1 at the top. It's minus 6 times 1. Equals 1 times 12x is 12x minus 2 times 4. So 10 minus 6 equals 12x minus 8. Bring the x's to the one side, numbers to the other. So minus 12x equals, and let's simplify this, minus 8 plus 6 minus 10 is minus 12, dividing both sides by minus 12. So x is equal to 1. Our restrictions then, the restrictions would be the same for all of these because we're going to divide. I'll show you that. 6x cannot equal to 0. Divide both sides by 6. So x is not equal to 0. The same thing would happen with all the others. So it's basically the same restriction. So you only have to show this once. So x cannot be 0. Our answer is not 0, so therefore it's still valid. Okay, the last one, we can multiply each term by 2 because that's the LCD, is 2. So times 2 times 2 times 2. So the 2's will cancel there. So we're left with 3x minus 2 equals 2x plus 2. And as you can see, what we keep doing in these questions is we're getting rid of the fractions by multiplying by the LCD, because you want to get rid of the fractions in order to get everything that looks on the same level so we can solve it. So 3x minus 2x equals 2 plus 2, that's 4. X is equal to 4. Our restrictions here, we don't have any restrictions because there's no variables in the denominators. There's only a 2, which isn't a variable. So there's no restrictions. Again, like I've been saying, we can check ourselves on the calculator. So you can put your x substituted in, and that will give you 5. And then on your right hand side, it's 4 plus 1, which is 5. So that's how we know we've actually done the correct thing, and this is actually our correct solution. Next is literal equations. So literal equations usually involve only variables and maybe 1 or 2 numbers. Okay. The point of a literal equation is to solve for a particular variable in terms of another variable. So you want to get that variable equals to the rest of the equation. We follow the same rules as in the other types of factorizing and equations. Okay, so let's work through this question. Solve for x in each of the following. So the goal is to get x equals in all of these equations. Okay. So, in this case, in this first example, the way we can get x by itself is to first factorize a common factor of x. So x bracket t plus p is equal to 4. Now we want to get x equals, so x by itself. So we divide both sides by everything that's not x. And then those two cancel, so x is equal to 4 over t plus p, and that's your answer. So you're solving for x. In this next one, a equals a third px squared plus 2. So we want to isolate the x squared. So first thing we can do is get rid of this fraction. So we can multiply each term by a third. I'm lying. Each term by 3, the denominator. So 3a is equal to, that 3 cancels, px squared plus 6. Now we can take over the 6, so 3a minus 6 equals px squared. Now we want to get rid of the p, so we can divide everything by p. So we are left with 3a over p minus 6 over p is equal to x squared. And now we want to get x by itself, so we square root both sides. But when we square root both sides, we've got to put a plus minus in front of the root sign. So your final answer is 3a over p minus 6 over p, all rooted, equal to x, and the plus minus in front of the root. Another way of writing the root is to just use one denominator, so all over p. So 3a minus 6 all over p and rooted. Okay, so all we're doing is we have to shuffle the equation, get x by itself, and then that's the answer. But you have to follow all the rules of algebra. So in this next example, px squared minus a equals tx. So first we want to get rid of whatever is not with the x, which is the a, so tk plus a. Then we want to get x by itself, so we divide everything by p. Okay, those cancel, so x squared, I'll put this all over the same denominator, so tk plus a. Now we square root both sides, And remember, plus minus, that cancels with the square to get x by itself. So therefore, your answer is the root of plus minus the root of tk plus a over p. Okay. Next one. We want x by itself again. To get rid of the root, we can square both sides. What you do to the one side, you do to the other side. So the square cancels the square root sign. So k squared is equal to wx over 15a. We want to get rid of the fraction, so multiply by 15a on both sides. So 15a k squared is equal to wx. We want the x by itself, so we divide both sides by w. So x is equal to 15a k squared over w. Okay, all you're doing is you're shuffling around the equation to get it in terms of whatever variable the question is asking. Then finally is simultaneous equations. So simultaneous equations involve two variables, and we have to solve for both variables. In grade 11 and 12, you might start working with three variables, but in grade 10, only two. So we have to set up several equations, starting with the most simple and solving for a particular variable, then using this value to substitute into the next equation. And just as a theoretical note, solving simultaneous equations provides the coordinates where two functions intersect. So if we were solving for two straight line functions, I'll just make this up, so this might not be accurate. Let's say that first function is that line, and the second function, let me change it to a negative, is that function there. When we solve these two functions and we make them equal to each other, we're solving simultaneously, and what it does is it provides you with this coordinate where the two functions intersect. That's relevant for the function section. In algebra, you get asked it with different equations. So here's our 2. X is equal to 2y plus 2 and x plus 2y equals 22. Your first step is always to get one of the variables alone. Always get one variable by itself. In this question, we're lucky because we have one that's by itself. It can be x, it can be y. If they use different variables, it can be any of the different variables. You just want one of the variables by itself equal to the rest of the equation. Okay, you don't need to do it for the y as well. We only need one. It might have been the y in another example. We just need one. X equals or y equals. We then make that equation 1 that we solved for x equals or y equals. The other equation becomes equation 2, and I like to label them, so I'd recommend you do that as well. Then we tell our marker we're going to substitute equation 1 into equation 2. So what we're doing here is wherever we see an x in equation 2, we're going to write 2y plus 2 because that's what x is equal to. So 2y plus 2 plus 2y equals 22. So you can see I've just substituted in this over here for x. And now our equation is all y's. There's no x's. This is the whole reason we do this. So 4y is equal to 20. Divide both sides by 4. Y is equal to 5. That value of 5 then becomes equation 3. And now we substitute equation 3 into equation 1 so we can solve for x. So instead of a y, we're going to put 5. So x is equal to 2 times y, which is 5, plus 2. And I'm all getting this from equation 1 over there. So x is equal to 10 plus 2. X is equal to 12. You can also then write your answer as a coordinate. So your x is first, your y is second, and that's your answer. Okay, let's do one more of those. So this case, we have 3x plus 4y equals 5, and 6y minus 7 equals minus 5x. So we again want x equals or y equals. So this one's a bit more tricky because we're going to have fractions involved. So you can pick any of them. I'm going to look at, you try aim for the easiest one. So I'm going to work with this one. You could also do this with the other equation as well. But I'm going to try and solve here first. So I'm looking at it, and both of them have coefficients. So the x has a coefficient, the y has a coefficient. So we're going to have to end up with fractions. So I'm going to solve for x. So 3x equals 5 minus 4y. I'm starting to isolate my x. Now I'm going to divide everything by 3 to get x by itself. Oops. Cancel the 3. X is equal to 5 over 3 minus 4y over 3. So now that is going to be equation 1. And the other equation will be equation 2. I've got my x equals. Okay, so I'm happy. Now I'm going to tell my marker, substitute equation 1 into equation 2. So I'm telling my marker what I'm going to do, and then I'm going to do it. So wherever I see an x in equation 2, I'm going to replace it with 5 over 3 minus 4y over 3. So 6y minus 7 equals minus 5 multiplied by 5 over 3 minus 4y over 3. Now let's solve. 6y minus 7 equals, so we're going to multiply this into the bracket. So minus 5 times 5 over 3 is minus 25 over 3. You can use your calculator for that. The next one, minus 5 times minus 4y over 3. Minuses times together will give you a plus. 5 times 4 is 20 over 3y. Y is to the one side, so 6y minus 20 over 3y equals minus 25 over 3 plus 7. And now I have to solve this. So 6 minus 20 over 3 is equal to minus 2 over 3y equals, and on this side, minus 25 over 3 plus 7 is equal to minus 4 over 3. Now I want to get rid of fractions. I'm going to multiply both sides by 3. And what happens is the 3's cancel each other. So we're left with minus 2y equals minus 4. We divide both sides by minus 2. So minus 4 divided by minus 2 is 2. That is now equation 3. And now I'm going to substitute equation 3 into equation 1. It's always easier to sub equation 3 into equation 1. So that then means that x is equal to 5 over 3 minus 4 times 2 over 3. So we have a common denominator, 3, and 5 minus 8. X is equal to minus 3 over 3, so x is equal to minus 1. Okay, so that is simultaneous equations. Exponential equations. So these are characterized by having a variable in your exponent. So immediately I can recognize this first one because there's that variable in the exponent. So your golden rule is to try get both sides of the equation to the same base. Generally, we do this by prime factorizing. So on your calculator, you should have the fact button. It's a shift function. In this first one, it's fairly simple because we know 3 to the power of what will give you 2. 3 to the power of what will give you 9. I gave away the answer. It's 2. But the way we do it mathematically, the maths behind it, is that we know the prime factor of 9 is 3 squared. So on your calculator, you can push 9 equals and then push shift and fact to get the prime factorization, which is 3 squared. Equals 3 to the x. The bases are the same, so we can drop them and just make the exponents equal. So 2 equals x. And that's your answer. Let's look at the next one. So in this example, our bases are already the same. So we can drop the bases and just make the exponents equal. And then we solve for x. So x is 2. Okay. Next one. So as soon as you see a number that's not prime factorized, it will usually be a big number. Because we want prime numbers, so we know 25 is not a prime number. So 5 to the 3x, and then we prime factorize 25. So on the calculator, 25 equals, and then shift fact, you should get 5 squared. We're going to put that in a bracket. X plus 1. What we can do here now is get rid of the bracket. So we're going to multiply this 2 with the exponent on the outside. So it's 5 to the 2x plus 2. Remember, we're multiplying into that whole thing. You can think of it as a bracket in that exponent. Our bases are now the same, so we can drop the bases and make the exponents equal. And now we solve for x. Bring over the 2x, so x equals 2. Okay, that's the last question. I hope all of that helped. And that is a basic summary of equations for grade 10.